In physics, the mechanical properties of solids describe how materials respond to various external forces and stresses. One of the important properties is the elasticity. Elasticity is the property of a material to return to its original shape and size after a deforming force is removed. A good example is a spring or a rubber band. When an external force is applied, it stretches, and when the force is released, it comes back to its original position and shape. Like a rubber band and spring, all solid materials exhibit elastic properties within their elastic limits. The solid material can be in the form of a coil called a spring, or it can be in the form of a rod or a cube. Similarly, the external forces can be applied axially or volumetrically or laterally as shown in the diagram. Our focus of discussion today is on 4 topics. First one is Hooke's law and its application to mechanical spring. Second one is Young's modulus and its application to long axial solid rods with axial force. Third one is bulk modulus and its application to solid cubes or spheres with volumetric forces. And finally, on modulus of rigidity or shear modulus and its application to solid cube or rectangular cube with external shear force. Let us take a spring with one end fixed. The other end of the spring is connected to a weight to produce gravitational force F. The spring gets stretched by an amount x. Now change the weight to 2 times the initial weight and the spring stretches by twice the initial amount. This means to say that the extension of the spring is proportional to external force applied. This proportionality constant is called Hooke's constant or stiffness of the spring. Mathematically, force equals minus k times x, where k is called Hooke's constant and x is the extension of the spring. Negative sign indicates that the spring produces an internal force that opposes the applied external force. In this equation, a spring with Hooke's constant k experiences an extension of x when an external force F is applied. You are asked to find the new extension if the force is doubled. Use the Hooke's law formula F equal to minus k times x. If the new force F dash equal to 2F, the new extension x is given by minus F dash divided by k, which is equal to minus 2 times F by k, which is also equal to minus 2 times x, where x is the initial extension. So if the force is doubled, extension will also double. Note that if stiffness is doubled, extension will also become half of the initial value. If the solid material is in the form of a rod like the one shown in the figure, and when an external force F is axially applied, the rod extends by delta L. Similarly, if the rod is compressed, the length of the rod also shrinks by delta L. This is due to elastic property of the rod, and this property is mathematically expressed as Young's modulus, which is equal to stress divided by strain. Stress is force per unit area. Strain equals change in length divided by original length. The Young's modulus is constant for a given material within its elastic limits. Let us understand the concept with an example. In this question, the original length and the cross-sectional area of the steel rod are given. Force applied and extension of the rod are also given. You are asked to find the value of Young's modulus. Recall the formula for Young's modulus and straight away substitute the value given as shown in the diagram. The unit of Young's modulus is Pascal. Bulk modulus throws more light on volumetric compression or expansion of solid cubes, rectangular slabs or spherical balls when uniform force is applied from all the directions. If delta V is the change in volume and V is the initial volume and F is the force on each face with area A, pressure equals force per unit area, bulk modulus equals pressure divided by delta V by V. This formula is applicable to spherical shapes as well. The next question is based on bulk modulus. In this question, volume pressure, change in volume and bulk modulus are given by parametric value. If the pressure is doubled, what will be the change in the volume? Use the formula for bulk modulus, B equal to pressure divided by delta V by B. Here P is the pressure, which is going to be doubled, and substituting the new value of pressure in the original equation, you will find that the new change in volume is twice the initial volume. If the force is applied normal to the surface, it is called shear force. For example, scissors exert shear force on a piece of paper or a cloth. Materials offer resistance to shear forces. It is easy to cut a piece of paper with a scissors, but it requires more force to shear an iron sheet. Modulus of rigidity is also called shear modulus. It explains material behavior when shear forces are applied. Modulus of rigidity is defined as the ratio of shear stress to shear strain. Shear stress equals force per cross-sectional area. Shear strain is expressed in theta. The next question is based on shear modulus. A solid cylinder of radius r and length L is subjected to a shearing force F. Lateral displacement is x at the top surface. If the shearing force is doubled, what is the new value of the lateral displacement? Use the formula for shear modulus, which is equal to shear stress divided by shear strain. Shear stress equals force divided by area. In this question, only force is doubled. Substitute the new value of the force in the formula. The new value of lateral displacement is twice the original displacement. We have come to the end of this video. Thank you for watching.